On this molecule, how many stem cells do you see? 1, 2, 3, 4, or 5. There's a 5 carbon, so it cannot be more than 5. Stem cells are carbon with a 4 different substituents. This one, that one, this one's a stem cell. Not that one, right? Not this one. So 3 stem cells. So how to draw this Fischer projection? You draw like this, but that's bad. I'm putting the carbon backbone in the vertical line. That's what normally people do. You can draw the Fischer projection long, wide, but that's not traditionally you draw the Fischer projection that way. That's not normally the way. You get the carbon backbone in the vertical line. And then these are the representing one of these stem cells, and that one should be this one. And the question is, which one should go top, which one should go to the bottom? I mean, you can draw in either way, but traditionally, we put more oxidized carbon on the top. So we're talking about CH3 versus COOH. Which carbons are more oxidized? Name oxidized means I'm having more oxygens on it, right? So carboxylic acids are more oxidized. So we typically put those carboxylic acid on top, I mean the more oxidized one. And then this one is going down. Then you gotta find out what goes where in each horizontal line. That is what it becomes. So which carbon does this one represent? Is this carbon that carbon? No, right? We just talked about this carbon had bearing the carboxylic acid. That should be this one. To draw the Fischer projection, should I look at the molecule from the top or the bottom? You have to make the vertical one going away from you. If you look from the ceiling looking down, these two vertical lines, these two carbon lines, is actually coming toward you, right? That's the perspective. So you shouldn't look from the top, from the ceiling. You should look from the floor, looking up. That way, this vertical line is going away from you, right? That's how you find out. And then my head is here. Why I put my head is up there? Because I put the carboxylic acid on top. If your head is here, carboxylic acid is going down. So you have to not only put the right perspective, you got to looking at the right direction as well. So looking up from the ceiling this way, you got the OH is coming out of the screen, right? That is on your which side? Left-hand side. That's why it goes there. Now, moving on to the middle one. If you look from if you still lying down, looking up, these two vertical lines is not going away from you. It's actually coming toward you. So that means that you should change your perspective. You got to look at from the ceiling, looking down, to make this two vertical line going away from you, because that's a Fischer convention. If you do that, you got the methyl and hydrogen. The methyl is behind the screen, right? So I'm looking down from the ceiling, right? I'm looking down from the ceiling. Methyl is behind the screen. Is that on my left-hand side or the right-hand side? That goes on the left-hand side. Now coming back here again, now this one, you cannot look from the ceiling because of that way you have these two bonds coming toward you. So you have to look on the floor again and looking up. And you got the bromine going away from the screen that is on my right-hand side. So that one goes right. So you got to keep changing your perspective. You're going to draw it without redrawing. So, but it can be doable. It's not that bad. It's just have to do it with practice. I want to talk about this one really fast. How many stem cells are here? 2, right? So I got just 2 lines here, right? A lot of people do this. And I'm saying you shouldn't. This is not the right way. Why? If you do this way, this carbon is connected to that carbon. You got this carbon connected to that one directly. Except you got the CH2 right there. Then how are you going to draw the Fischer relation of that one? Should I draw this way? I got one cross there, connected to CH2, another cross there. Then it looks like probably something, right? No, that's not right either. So what do? You count here to there, all three stairs that are drawn. And in between these two, which one I should put normally? The one with the more oxygen, more oxidized carbon. So I should put the oxygen this way, line angle drawing connected with the Fischer drawing. I know sometimes people do that, but it's not the normal implementation. When you do Fischer drawing, don't mix with a line angle drawing. Normally you do CH2OH and CH3. That should be the way to put it. And then this one, that's this carbon. Then you gotta looking from the top, right? You can look at looking from the top to make these two bonds in the horizontal, two bonds in the vertical going away from you. Looking from the top, fluorine is coming out the screen. That's on my right hand side. So fluorine should go here. But what about this position? What do I do? That's not stereo center. However, we should draw it because we gotta make a connection going between these two carbons, between those two carbons. So that's why it has to be drawn. But that's just going to be two hydrogen. So that one's the two hydrogen there. And then the next one is this is the same thing. You gotta look from the top because you want to make this vertical line going away from you. Now the horizontal line, oxygen is coming out of the screen. That's the same position on my right hand side. So it should be there. But sometimes, often cases when people ask to draw the Fischer drawing of this one, they're missing this one. They just put it like this and occupy all the bond. That's the reason I want to cover this one. Don't forget that CH2 in there.